Good evening, everyone. My name is Errol. Today's date is September 13th, 2009, and this is Planetary Television. Now, in less than a month, on October 9th, 2009, the Lunar Crater Observation and Sensing Satellite will be purposely impacting a crater on the south pole of the moon. Now, what makes this exciting is, for the first time, or one of the few times, that amateur astronomers may have the opportunity to watch it as it happens. Anyone with a telescope between 10 to 12 inches, or anyone who wishes to photograph the event, has the opportunity to capture any type of plumes. Now, I wanted to take this opportunity to give you an idea of what you might see, and also where to look on the moon. Now, what we were revealed is the fact that NASA has chosen the Cabeus A crater. The Cabeus A crater lies on the south pole of the moon. During the night of the observation, it will be very near the terminator, or the dark line light separation of the moon, which will give a good opportunity for those who are here on Earth to view any type of plume that may be illuminated from the sun with the dark shadowed background. Now, the reason why they chose this crater is the fact that its angle in respect to the Earth, as I spoke, will allow a plume to be able to eject out, of which point the front lit light will allow us to visually see a plume. Now, what's going to happen is, before the actual satellite itself crashes into the crater, it's going to eject its spent Atlas rocket, which was the rocket that was used to propel it to the moon in the first place. It will send it at an angle first towards the crater, at which point it will blow up into the crater. At the same time, a big plume will expand out of dust and possibly liquid or ice water, or water ice. And so, at which point the satellite itself will actually fly through this cloud and hopefully detect any type of hydrogen or ice water. Now, I want to take this opportunity, before I go into the details as to where to look for the water, or where to look for the impact with your telescope, is to give you an idea of what the impact itself is going to look like and what goes into it. The primary goal of LCROSS is to measure the concentration of water ice, or ice to dust ratio, in permanently shadowed lunar regolith. In this case, it's going to be Cabeus A. Now, setting constraints on water ice will set a fiducial for the Lunar Reconnaissance Orbiter's study of hydrogen neutrons that are expected to have water ice as their source. Several important processes occur when a body strikes the lunar surface, including the initial impact, ejecta, and plume dispersion, and the exposure of fresh subsurface material. Now, continuously monitoring the impact event at a variety of spatial meters to kilometers to exposure scales and temporal scales, seconds to minutes to days, allows us to understand lunar impact processes and assesses the likelihood that water ice, due to the impacts occurring within the permanently shadowed target crater, may be distributed non-uniformly. Now, the slide that you're viewing now is of the suggested impact over a duration of time. The first one shows the plume after 1 minute. It suggested a spatial scale of about 10 meters. 10 meters would be approximately 90 feet diameter. The second one is showing after 10 minutes, the plume itself will expand up to approximately 10 kilometers. Now, as you may notice at this time, the subrising H2O, the H2O that may be encased within the crater, will rise above the plume, at which point, after an hour, the plume will expand to about 100 kilometers, at which point, due to the external exposure and the chemical reaction that may occur on the impact, free oxygen and hydrogen molecules may be detectable, at which point we would be able to detect whether or not there was water ice or if there had been hydrogen within the crater. The upper stage of the launch vehicle, which is the Atlas rocket that propelled it to the moon, about the weight of a large SUV, will impact into either side of the canyon. There is a small crater on the upper left, which they are aiming for, which is more perpetually in the dark and has a higher probability of having ice water. Now, the Atlas rocket itself will be propelled towards the moon at over 9,000 kilometers per hour, which is about 5,600 miles per hour. The impact will excavate a crater about 1/3 of a football field wide and about the depth of the deep end of a swimming pool. The amount of material, dust, and probably ice ejected could fill 10 school buses or 10 space shuttle cargo bays. The plume will reach nearly 50 kilometers high. That's over 30 miles. Now, this is the opportunity for the Amatuer Astronomer to view the plume from Earth. At which point, I want to move this on to exactly where this impact is going to be. Using Starry Night Pro, I can show you what the moon's going to look like at approximately 4:30 a.m. plus or minus 30 minutes on October 9th, 2009, which is the estimated time in which the impact will occur. The impact is going to be on the southern pole, down the south pole. What you need to do is find this bright spot here, bright crater, at which point it's you can view closer in, and once you get closer, you can locate the larger crater, which is here, with the smaller companion crater, and KBSA would actually be kitty-cornered directly from in this location. So when you go to observe the crater, the area, focus most of your attention on this section of the South Pole. I wish I could show you it on a clearer resolution, but the screen capture program I'm using degrades the image greatly. So if anyone has any suggestions as to a better capture to use, please let me know at PlanetaryTV@gmail.com. But if you zoom in a little bit more, most likely at this point you can't see much, but you have the bright crater here that I first showed you, plus the large crater with the companion crater here on the side. If you take it directly over in this direction, and down below the big white crater, this is approximately the location in which the KBSA is. Now, if you're viewing it from Earth, when the impact occurs, you're gonna the visual hopefully would be seen because the sun will be illuminating through the plume, which hopefully you can see even like a bright speck. So if you're photographing the location, to just continue to photograph using your proper shutter speed, just so you can get the proper the lighting. Thank you for joining me. This was Errol Coder. If you have any questions, please contact me at PlanetaryTV at gmail.com. And I'm open to any questions regarding this observation period. Thank you very much. This is Errol Coder, Planetary Television. And as always, keep looking up.